Okay, so what you should have noticed by going through that exercise in the previous video is that this absolute value function has the same shifting mechanisms as we had with parent functions in Unit 1. And so you can see here we can actually generically represent a lot of this shifting. And so inside the absolute value function, we're going to call this an h. So x minus h is our generic representation of that translation. And so if you remember, the h on the inside shifts the graph left and right. And so you can simply say that the h is going to shift the graph left or right. Now, if you recall, it always seems to be doing the opposite of whatever value is inside the absolute value bars. The k value was added outside of the absolute value bars, and it always shifts the graph up or down. And of course, it's doing exactly what the sign is telling us it's doing. And then finally, the a value in front of the absolute value bars is making the graph steeper or wider. And we can call this compression or stretching. I like to use the more generic terms of making it steeper, making it a little bit wider. I think that kind of makes a little bit better understanding of what's going on with the graph itself. And so you can remember that all of the absolute value graphs are a V-shape with a vertex, and that if the a value is negative, it also flips it down or reflects it across the axis or whatever line it's on. And then all of the other translations and dilations work the same. So we have, translations, reflections, and dilations similar to what we had in Unit 1 that are going to apply here. So what my goal is to get you to work problems like sample problem number 2 without the benefit of a calculator. So can you work these two sample problems simply by understanding what each part does to the parent graph? So what I'd like you to do is pause the video, try part A and part B, come back and look at the solutions, and or you can use your calculator to check your final answers for each of these and see how you did. So go ahead and pause the video now and work on that. Okay, so I'm going to go ahead and work part A for you. And so the absolute value of x by itself is just basically from vertex 0, 0 with a 1-for-1 slope or a -1 slope, but it's over 1, up 1, over 1, up 1, and it's going to create this V shape. Now, this multiple in front of this is 1/3, and it's less than 1. So that is actually going to create a flatter or wider looking graph. So if I want to think about this similar to rise over run, I could simply go up 1 over 3, up 1 over 3. Now, that's positive on the positive sides of x. However, on the opposite side, remember it's a negative slope, so it's up 1, back 3, up 1, back 3, and so we have to go that way to kind of create our V shape, and so that would represent 1/3 times the absolute value of x. Okay? Now, if I want to do part B, I can see here that this 3 says x minus h, so the 3 is the h, and plus 1 is the k, and so that actually represents our vertex. Now you can also see that this negative value is going to make it flip or reflect across the particular line that it's on. So I'm going to first graph the vertex. 1, 2, 3, 1 seems to be sharing a point there. And then it's down, so I'm going to go down 1 over 1, down 1 over 1, still a 1-for-1 transition, and I simply have to draw the downward absolute value graph. And so there you have it. You hopefully have been able to graph these two absolute value functions without the help of a calculator, and hopefully without the help of t-charting. You just are starting to understand the transformation process that is taking place. Okay, so the next video we will actually learn how to write the equations of these absolute value functions.